Hello everyone. Today I will show you how to analyze of simply support structure using Etabs. Okay. Um, this is our simply supported frame. Is a beam with load. We can assume anything, and we get the bending moment diagram, shear force diagram. I will show you how we can do this in Etabs. Okay. Let's start from Etabs. Okay. I will open from Etabs. It's very easy. I will show you how we can draw the bending diagram, shear force, and displacement. Okay. Now go to new, and we can use any setting. If you have different, like if you're going to use Europe, Canada, we have different one. But I will not use this setting right now. I use the safe setting. You define. Okay. I click this one, and this is our portfolio. This is our screen. Okay. This is disturbing me. Okay. First of all, if we're going, we do not need any dimension because it is like it's two line and one axis. Okay, just I'll click the uh, blank template. Then we'll get this one. Okay. This is our screen. Then it is showing like 48 feet. Now we'll change the unit to uh SI unit, and we get our frame. Okay. But we change our unit. Now I'm going to draw the grid that we need the grid to draw it in any project. Look, it has at A axis and B. Similarly, I can write okay grid. I can edit story and grid line, and I can modify system. Okay, this one. Just I need a grid. Okay, just assume it whichever you want. Okay. You can write coordinate or anything, but I will write display grid data on spacing. First of all, we need the mm, horiz two horizontal line for A and B. Okay, and then for y-axis, then we need only one line AB. Okay, okay. For that, I will add two here and here one. Just I give a name it A, and I'll give the bin B, and keep spacing how much you want. Like I'll keep the spacing 20 meter. For B we do not need because the spacing B is the in point, and in the y direction just sorry, I don't need to keep any spacing. Okay, but then I'll come here. I'll give the name to it like coordinate 1, and for it 0. Because why we kept 0? Because it do not have any spacing. It's only the one axis, this line beam where we keeping the line. Okay, then I'll keep okay, and I'll modify it. Then we get our point here. Okay, let's see in the elevation. We can see in the elevation. Anyone you can click. Okay, I'll click the one this, and we can see it. Okay, I don't need this one. Okay, this is our axis. Okay, let's draw a beam here. At the point of it reached any story. Okay, just click the line here. Draw a beam. I'll keep here to like 20 meter. Okay, this one the beam. Then I'm going to assign it the support. We need the support. Okay, I will assign it the support. From support we will go to joint and restraint. Just I'll click the point where we want to assign. First of all, I want to assign here. I want to assign here. Okay, then I'll assign joint, assign joint restraint, and which support you want to keep. Okay, I'll keep it fixed. Anything you can just click. I'll keep it hinge. Okay, apply it, and okay, here is done. Then I'll keep here another support assigned joint, resting. Then I'll keep a roller. Okay, or pin. I don't want pin. Okay, I will keep both hinge support and apply it. Okay. Next of all, we need to assign the load for this one. Like to assign our load, you can go to assign. Then it's the point load. If we will go to frame load and then apply it. But it's the sail load means it's the like for the wall, for the roof, like for the slab we use the sail load. But we are going to assign it for the frame load. Then we are going to use the point load for this one, and it's can the point the frame may have both load like point load or date load anything live load or a date load, but we are going to use date load. There is no any point load. Then you have to like force or momentum you can apply it, but we are going to apply it only the uh, force. We do not we are not going to apply movement. We can apply movement on it also. So grab, then here is the direction of load application. We have local axis, global axis, gravity. I'll tell you later on about the every portion, but we are going to apply the it's particularly downward, so we are going to apply gravity for it. Okay? Mm, and next one will be the relative distance from indi, like from the can I move it? I try to make it small. Okay, sorry, I cannot move it. I think. Okay. Oh yeah, sorry, I can move it. Okay. Relative distance from indi means we have the distance about 20 meter, and its distance like distance means the zero, uh, 20 meter, and we have the load at point 10 meter. That means 10 divided by 20 means it is 0.1 or 0.5. Like it is means it is in center means 0.5. That means it whole is 1, and every point load acting from this point it will taken as 0.25 some point somewhere at the first quarter, and then 0.7 quarter is next point, and 1 is the end point. By this way it is and it is given to it is given the distance by it, but we are not going to use the relative distance from indi. We are going to use absolute distance from indi. Absolute distance means actual distance as distance 0 from a, we have 0 load, and at the distance something right here. Okay, at the 10 meter we are going to put like 20 kilonewton loads, and at the like we don't have any load if 15, if you have loads of something you can keep here. If you have 20 meter you can keep here. By this way we can assign the load at different meter, and we have another option also. If we are going to assign the load on the same points like in the same beam, and we can add the load there, like if we add the load the existing load, like if we apply just 20 kilometer right now, later we apply, and if we again apply the load on the beam at the same distance like 10 kilometer, we can add to the existing load. But if you choose the options replace the existing load, it will then replace the load. Like if you we are going to some mistakenly we keep the load 10 kilonewton, but we need the 20 kilonewton, we can select the beam and write 20 and replace the existing load. Then it will keep that load. If you do not want any more that load, you can choose the option delete the existing load, and you can delete it. Okay, by this way we can replace our load or add the existing load or delete the load which we do not need. Okay, by this way uh, I'm going to apply the load on our beam. Okay, oh, sorry, it's not selected. Sorry for that one. Okay, I just want to select it. I just want to select this one. Assign. uh you know what, it's everything like that. Okay, absolutely. Okay, everything is same which I have already explained it. Okay, 10 meter I want to apply. Hence, okay. Now we can see our 10 kilonewton load. Okay, we have defined our support, everything. Okay, now we want to run our analysis. Just click the run analysis. and we need to shift it. Okay, simply supported imported beam and save it. Let's just run it. Okay, this is nothing like that. Okay, done. If you want to check some everything right or not, we can check the model here and run the analysis. Okay, this is our deflection. Now we want to show the support reaction. Okay, apply FX. We can see that is given 23.76, 23.76. But on the basis of our load, like we have kept 20 kilometer, we have kept 20 kilometer. It must be like 10 kilometer here, 10 kilometer, but it's showing more than that. It is showing mm, more than that. 10, 10, but it's showing 23.76. Why? You can see it's showing more. Okay, let's see on the shear force diagram. Let's see on the shear force diagram. Oh, here is shear force diagram, shear force 22, apply and sheet. Oh, you cannot see the value. It is on shear force 22. You can show value on controlling side. Then we can see this. It is 23.75558 and minus 23.7555 like that. It's more than which we calculate. Why it is, I'll explain you later. And we'll see the movement. It is movement at axis, and we can see it's 160. It's more because this while it analyzes it assumes the load of beam also. But when we do our hand calculation, uh, we do not assume the load of beam, so we get a different value. Look, mm, you can see WL by, if you calculate it, you get the um less. It should be less value, but it's giving more value. WL by 2 and W by 2, W by 2 indeed we have, and WL by 4. Okay, let's change it. Okay, uh, I will select the reaction. Now just we'll change the properties like material property, selection properties, edit, view. So we'll go to material properties. Oh, no, 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 sorry.
Showing. I will discuss you later a bit show the uh, why these difference are showing because to see the load app. Okay, so before that, mass one and go for assign frame.
Okay, then we'll go to assign, then frame, modification. Look, it is showing that mass weight is 1 and weight is 1. So we have a different result. So I'll just keep it mass give it 0 and weight with 0 and apply it. S- Just I'll select the frame, assign frame, uh, properties modifier, keep this one 0 and weight with 0 and apply it. Okay, let's check it, and we'll go to the analysis. We'll check the model. Everything is correct to know. Uh, select. Okay, and no model check, no warning message generated. Then we'll go to analysis. Yeah, no, this is not just a message, analysis message. And we'll go to see the support reaction. Okay, yep, chat. And we'll see that we'll get a 10 10. And then it will check the surface diagram, surface 2 2, and applied. And okay, we'll get 10 and minus 10 value, which we need like based on our theory. Okay, then let's go to the surface diagram, light and okay, which is WL by W. W means 10 into 20 divided by 400. Yes, 20. We get the exact value. By this way, uh, it's like sign convention, it is going downward. It's just the value. There is nothing else. If you click on the beam, you can. If you click on the right click on it, you can get everything like evaluation loop. Load here. Then we go shear force, then mundane diagrams and deflections. Everything we can get it. Okay. By this way, we can analyze we can analyze our load, our uh, simply supported beam in Etabs in easy and effective way. If you need like any other load, you can add at a point and analyze it. It's very easy and you can do it. Thanks for watching.